Okay, in this video we're going to take a look at just a couple of trig problems here where we're needing to find the exact value of the expression, and they do involve those inverse trig functions. Alright, this one, the inside portion is not an inverse. In this one, the inside portion is an inverse. So it will be two different approaches here. When I've got the inside part of this function and it's not an inverse function, then I can just use regular trig and find the value of that. Okay, so things that I'm going to think about here, I'm going to look at my unit circle. Negative pi over 2 is going this way around the unit circle. It would be this location. All right, on my unit circle, going counterclockwise, there's negative pi over 2. The ordered pair that corresponds to that is 0, negative 1. All right, we know that the first coordinate is the cosine and the second one is the sine. All right, but they're asking for the cosecant of negative pi over 2. All right, so I'm going to take a look at my reciprocal identities. Cosecant of theta is equivalent to 1 over sine theta. Okay, so at negative pi over 2, sine is negative 1. So then 1 over negative 1 gives me a value of negative 1. So this inside portion here has a value of negative 1. Okay, so then what I've got to do is I'm now going to try to find the inverse cosine of a negative 1. All right, now to do this, I am going to take a look at my unit circle. So we'll pull out a unit circle. Maybe darken the screen a little bit so that'll show up a little bit better. All right, now restrictions on my cosine, all right, is in between negative 1 and 1. Okay, so my domain restriction on my inverse cosine function is in between these two. So what I'm going to do is I'm going to go look at every ordered pair, and I'm going to look at the x coordinate because that's my cosine values until I find negative 1. All right, well, looking at those x coordinates in just those two quadrants, negative 1 is right here at pi, so the angle that gives me a cosine value of negative 1 is pi. So overall answer to this would be pi. All right, now taking a look at this second problem. All right, we are going to have to take a little bit of different approach because my inverse trig function right here is on the inside. Okay, so I'm going to use a little right triangle portion of my bow tie triangle and figure out where this goes. All right, the cosine value here is positive. Okay, cosine value is positive. All right, so if you remember, all students take calculus, or however you want to remember this. All trig functions are positive here. Sine and cosecant are positive here. Tangent and cotangent are positive in this quadrant. Cosine and secant are positive in this one. All right, I know my cosine value is going to be positive. All right, which means I have options of these two, all right, but then I have to remember my restriction on my inverse cosine function. All right, my restriction on my domain there is negative 1 to 1, which means I have to pick one of these two quadrants, okay, from negative 1 to 1. So this one's out and this one's out. All right, we've already said cosine's positive. The only quadrant that cosine is positive in is here because I only have two to choose from. It's negative here. So this means that I'm going to write my right triangle in my first quadrant right there. Okay, so I'm going to come over here. I'm going to draw a first quadrant, part of my bow tie triangle. All right, now we're going to take a look at this cosine here. If I did, let's make it so it looks a little more official here. Theta is going to be cosine of 1/6. Okay, so cosine, because this is the inverse function, all right, cosine in a right triangle definition is adjacent over hypotenuse. My theta is right here, so my adjacent side is going to be this side right here, so this side has to be 1. My hypotenuse has to be 6. All right, I can use a squared plus b squared equals c squared to find this missing side right here. So 1 squared plus my missing side, b squared, equals 6 squared. So 1 plus b squared equals a 36. Subtract 1 from both sides, b squared equals 35. So my missing side there is going to be the square root of 35. So my missing side here is square root of 35. Now, as long as I've got this, all right, I've done the inside portion of this. I've used my inverse cosine. I've got my triangle, okay? So now I just have to answer the outside. Well, the outside part is asking me to find cosecant of theta. All right, well, again, since I have a right triangle here in my first quadrant, I'm going to use right triangle trig. Cosecant is hypotenuse over opposite. My hypotenuse of this triangle is a 6. My opposite side is square root of 35. If we want to go ahead and rationalize that denominator, multiplying by the square root of 35 over the square root of 35, then I'm going to have a final answer of 6 square root of 35 over 35 for a final answer there. So clearly, more work when the inside portion is an inverse function and the outside is just a regular trig function. All right, and here, when that inside function is just a value that you can really easily find on your unit circle, find that value, and then you work on the inverse of that for the outside function. So just a couple quick examples here of finding some exact values for trig expressions. Definitely thanks for watching. If the videos are helping, be sure and share with your friends so that they can benefit too. Thanks.